In previous class, we have discussed about different characterization of artificial neural network. Now, we can have the discussion of different types of network. This is the example of single layer feed-forward network. So, here single layer means there is one input layer and one output layer. Here the input layer is x1, x2 and the output layer is ym and yn. So, here W1, W12, W21, W22 indicates weights. So, already we have discussed what is weight. So, weight means it provides the importance of the input information. Here W11 indicates it is connecting x1 with y1. W12 indicates it connecting x1 with y2. And W21 indicates it is connecting x2 with y1. W22 indicates it is connecting that is x2 into y2. So, this is nothing but single layer feed forward network. So, it is moving in the forward direction. It is feeding, that is the input is feeding into forward direction. So, it is called a single layer feed forward network. This is one example, and this is called a multi-layer neural network. So, here there are, instead of single layer, we are having different types of layers. For example, x1, x2, and there are many number of channels. So, here x1, then we have got then a hidden networks, then we have got a output networks. So, here the weight we are providing the weight in between input as well as hidden layers, and as well as we are providing the weight between hidden layers and the output layers. So, here the input is given to, there are Z1, Z2, Z3, that is called hidden layers. So, X1 it is connecting with Z1 as well as Z2 as well as Z, that is Zn. Similarly, X2 it is connecting to Z1, Z2, vice versa. And similarly, Xn is connected with X1, X2, vice versa. So, here all the layers are connected with all the other layers, that is nothing but multi-layer. So, in previous, that is called a single layer, means one single layer is present between input as well as output. But here there are different types of layers which is present between input as well as output. So, input unit, processing unit, the different types of layer is known as, also known as, that is called hidden layers. Then here we are applying the activation function in the hidden layers, that is activation functions in the hidden layer as well as output layer. So, the weight between the input as well as hidden layer also we are applying, as well as the weight between the hidden layer as well as output also we are applying. So, this is nothing but multi-layer neural network. So, now we can have the clear difference between single layer feed forward neural network as well as multi-layer neural networks. That is a clear difference. Next, recurrent neural network. Here we can see the difference. Recurrent means, so it is past data also it is comparing. So, here it is input as well as we are output. See, you can have the hidden layer, and hidden layer there is a in backward direction they are updating the past information. Here the input is first one, next one is hidden layer as well as output. So, here in backward direction they are sharing the information. So, here the indicates, please see the difference. The arrow mark is indicates, the arrow mark provides the backward direction signal from the hidden layer into input layer. You can see the difference. You can see the arrow mark, that is hidden layer 1, it provides a signal to input. Similarly, in the output side also we can able to exchange information. It is called recurrent. Recurrent means we can have the memory and we can compare the current data with previous data. That is nothing but recurrent networks. So, these are the different types of network which we are using in ANN. Then different types of learning. This also already we have discussed it. There are three types of learning. So, one is based on supervised learning, and one more is based on unsupervised learning, and one more is based on reinforcement learning. Supervised learning means a labeling is performed. A learning is performed by presenting pattern with target. That means we are having some target and we can able to find out the target by reducing the error. That is, we have to perform the training. If there is error, then we have to continue the training. If there is no error, that means we can stop the training and the learning is completed. That is, here the learning is performed based on some guidance, that is some labeling, that is called the supervised learning. So, there are different types of network in supervised learning, that is nothing but simple perceptron, then feed forward, then Adeline networks, then as well as radial based network, then as well as support vector machine. These are all the examples of supervised learning networks. In our syllabus, what we are going to study means in supervised learning, we are going to study about simple perceptron, then we are going to study about adaptive linear neuron, and we are going to discuss about multi-layer Adeline, that is adaptive linear neuron. Then finally, we are going to discuss about back propagation networks. So, these are the different types of network or neural network which we are using in the category of supervised learning. Then unsupervised learning, here that is the labeling is not given, the network itself or the network learns by itself, that is unsupervised learning. So, here the learning is performed by the network itself. It will take some time and it will predict the that is target value based on learning by itself. here some examples are called MaxNet and learning vector quantization and radial based learning. So these are all the different types of learning comes under unsupervised learning. Then finally we have got reinforcement learning. It is another type of learning. It is working based on feedback. That is, if you are doing good means it provides a good one. If you are not doing good means it provides a penalty. For example, robotics automation, pathfinding, these are all the very important applications where the reinforcement learning is applied. So these are all the different types of learning algorithm in the artificial neural networks. See here, unsupervised learning. Here the targets are not provided appropriate for clustering data. For example, mainly this unsupervised learning is useful for clustering the network. For example, different types of clustering problem, like maximum likelihood problem, neighborhood problem. In this type of applications, we can go for unsupervised learning, because unsupervised learning, very few number of learning that is data sets is enough. But for supervised learning, we have to provide large number of data sets. But unsupervised learning, few number of data sets is enough to perform the learning process. So this is nothing but unsupervised learning. So here in unsupervised learning, the target is not given. So the network itself will learn. That is nothing but unsupervised learning. The example is called coherent self-organizing maps, then Hopfield networks. These are all the different types of neural networks which is based on unsupervised learning. And finally, we have got reinforcement learning. Target is provided, but the desired output is offset. So the net is only provided with guidance to find out the produced output is correct or vice versa. So weights are modified in the units that have errors. So here the target is provided, but the corresponding output is absent. So the network will get merits or demerits. If it is finding correct, that is comes under merits. If it is not finding correct, that is comes under demerit. That means good as well as penalty. So here feedback or errors can be given to update the weights to improve the training, that is learning parameters. Then finally the learning will happen. That is nothing but reinforcement learning. So these are all the different types of learning networks which we are learning algorithms which we are using in the deep learning model to neural networks to perform the learning process, because this learning process is essential. Once the learning is completed, then only we can implement our any AI model or any neural networks model into real-time networks. So without learning or without training the model, we can't directly implement the model into real-world problems. Like for example, a student is going to write the examination without studying or without preparation, he can't get some good marks. For example, he may get some 20 marks or 10 marks, but it is not possible to get full marks. Similarly, in a network, for implementing into real world or implementing into practical applications, we have to perform the training. Once the training is completed, we have to perform the testing, then we can implement into real world. Then only the network will work. Otherwise, we can't say, it can't produce the expected outputs. So these are all the different types of learning algorithms which we are using in the artificial neural networks. Okay. Applications. So there are enormous applications of artificial neural networks. We can use for medical applications, we can use for diagnostic applications, we can use for military applications, we can use for that is human computer interactions. Then we can use for civil oriented applications, we can use for fault detection, we can use for mechanical applications. So we can use for environmental applications, we can go for integration with the IoT. So there are numerous number of applications which are available of artificial neural networks, which is all available. We can implement all this ANN into almost all type of applications. Nowadays they are implementing IoT with AI model to provide solutions for the real world problems. Okay. So in next class we can discuss about the different types of supervised learning models.